Welcome back to our second presentation for the day. And the next presentation was pre-recorded. It's about the power of personalization, and it will be presented by Dino Bernicchi, the head of machine learning at Home Choice. Let me start it shortly.
Hi, everyone, and welcome to my talk. My name is Dino Bernicchi. It's a pleasure to be here. Unfortunately, I'm not here in person, so this presentation has been pre-recorded. I'm currently head of machine learning at Home Choice. Home Choice is a home shopping and financial services group based in Cape Town, South Africa. I've previously consulted to large corporates such as TFG, Woolworths, Standard Bank, helping them develop and roll out recommender systems and personalization systems. And currently I'm consulting to Andrew Ng's deeplearning.ai, helping them develop their course content. And I've also been dabbling in some creative apps recently through a side project called Face. So if you want to check out those apps in the App Store, you can do that. Today, I'm going to be talking about the power of personalization. So reflecting on some of the recommender systems that I've developed for retail clients, which are more traditional systems, and then looking ahead and seeing, well, what else can be done in the recommender space using sort of new tech or newer tech in computer vision and reinforcement learning, and how can that be applied to e-commerce websites. So let's kick it off. Personalization systems are driven by two different types of recommender systems, either neighborhood-based or model-based. What is that exactly? I drew up some quick examples here. So neighborhood-based, there's actually two examples here. So either you look for similar users. What constitutes a similar user? They have similar purchase history. So here user A and B have both purchased the same blue top and blue shirt, and therefore we define these customers as being similar. And then you had the red t-shirt was viewed or purchased by customer A, but not yet by customer B. Therefore, recommend that red shirt to customer B because we think that person is similar to A, therefore show it. Similar, but in a different vein is if products are similar. So we have some attributes on the products and we determine the products are similar. If the customer looks at one of those similar products, it makes sense to recommend the other similar product to that customer at some point, either in the current session or in the future. Model-based is more of your traditional machine learning models. So you input historic data. There's algorithms that sort of look at that data and learn patterns in the data without any sort of explicit coding instructions. And then the machine will generalize those learnings and you can feed it current data and the machine can then make predictions based on patterns that it's seen in the past. So for instance, if it knows customers come in to your website and follow a certain trajectory of looking at products, it can then start to predict if a customer comes in and looks at product A, what is probably the next product that they will look at, or based on that customer's attributes, geolocation, most likely what is the product that that customer would likely want to see in this session, and making those predictions and then serving up those recommendations. So very simple. And here's just some examples of where these solutions have been deployed previously in some of my work. These are just examples of communications to customers where you're recommending specific products. This is a neighborhood-based approach to get these recommendations for one client, and for another client we used model-based approaches also to pick out specific products to recommend to customers. There were also some additional algorithms here to optimize for price or optimize for voucher value, but that's sort of beyond the scope of what I want to talk about here. And here's another one. This one is actually for Home Choice, where we used both neighborhood-based and model-based approaches depending on different customer attributes and different pros and cons of those approaches to create a hybrid system to deliver personalized product offers to customers. So you can see these methods are pretty effective, but they are traditional recommender systems that have been in the market for 10+ years. And with these traditional recommender systems, there are problems with them. The biggest one is they require huge amounts of data. The data is often sparse, because you often have a lot of customers and a lot of products. So what's the probability that you are going to be able to find lots of customers that have bought similar products when you have a very deep product catalog like most modern large retailers do? Product information might be inconsistent, or missing. And then also, what do you do when a new customer hits your e-commerce website? You've got no sort of user characteristics or behavior on that customer. You've got no views of different items or purchase history. And then the same with products. If you add a new product to your catalog and you don't really have solid product information on that, how do you actually then match users and items together? It's a big problem with these traditional recommender systems. So now let's just forget about recommender systems for a slide or two, and just think about the last time you went to a shop. How do humans normally shop? We normally shop with our eyes or with touching and feeling. And if you look at a garment or an item, you kind of consider the color, the materials, the style, what is the shape, what is the size. There might be other attributes here, but this is just sort of a summary of how a human actually looks at a product and says, okay, I like this, or I want something similar to this, and it gives you an idea. So what some new approaches in product recommendations has done is actually taken a human approach to it, and a more offline approach is, humans shop with their eyes. How do we find visually similar products and then recommend those products to a customer? And that eliminates quite a few problems with that you see in traditional recommender systems. But how do you actually do that? So how do you take images and then compare them and say this image is similar to this? Because images usually have millions of pixels. So there must be a way to do that. And luckily there is. So you can actually find a representation of that image in a string of numbers. And you can do that in a simple encoding, decoding neural network. And this is very similar to how facial verification or facial recognition systems work. And they actually find a representation for that face. And then the next time that user comes in again, the face goes through the same process and finds another representation of that face. And if the two representations, so the current one and the one on file, is similar enough, the system determines that it is the correct person or the right person, and the door unlocks or whatever in that use case. But in this specific use case for, let's say, retail, you actually want to encode your product catalog, the image of the product catalog, and then you can find similar looking items based on those encodings. So maybe another way to look at it is this encoding decoding process is similar to how you compress files on your computer. So you take a large file, you compress it into a smaller version of that file, an encoding in this case, and that encoding is good enough that it can be decoded back into the original image. Another way to maybe think about this is if you squint. So if you go into a clothing store and you look at a few garments and you squint, and it becomes quite blurry and small, but you can still see these certain items are different to these items, but now some items actually look more similar to one another. And if you open your eyes, they might all be blue shirts or something. And that's another maybe explanation of how the system works. But how do you actually train a system like this? Because you want the encoding and the decoding process to be quite good, so that that the representation in the middle for all of the tens of millions of images that you can put through this process is a solid encoding, and it can be reliable in any sort of distance metric where you want to find the similarities between the different items. So what you do here is you actually encode this neural network. I have simplified it quite a bit. There's a lot of pre and processing steps that have to happen before, but as an explanation here, it's a little bit simplified. But let's say you stick in a blue shirt. You want to encode that blue shirt into maybe, say, 8 numbers in this example. And then from those 8 numbers, that can go through a decoding process, and you would want to see the output being the blue shirt. But it might not be exactly the blue shirt because a lot of information has been lost in this process. But if you get close enough, that's good. And you keep iterating on the system until you get a very solid output that looks almost identical to the input, because then you know that this encoding process is working pretty well, and you have a good way to represent pictures as, for example, in this case, binary numbers. And that means you can then do, you can use these encodings to compare products based on those binary numbers. And it becomes a lot easier to compare products based on a small set of binary numbers than an image of a couple of million pixels. Just simple math. So how does this approach actually work in practice? So we would, and we did a mock-up of this, is we downloaded all the images from a retailer's website. We ran it through this then encoding process of ours and created encodings for all of the models. We can then calculate the similarities between all of the different images, which is quite quick and simple actually. And you can then rank products based on some similarity. So for example, in this case, the blue shirt is most similar to the red shirt based on the difference in those encoding values between the red and the blue shirt. And then the second most similar item is the yellow shirt, and then the green shirt in this specific example. So I think what would cement the concept is maybe actually seeing it in practice, where what we did is we took a couple of retailers in the UK and we actually ran the process on their website and then compared the current e-commerce recommendations to the recommendations that would have been produced by this encoding decoding process. So let's have a look at that. Okay, so here's an example of a retailer. The original product page is on the left, and it's that floral dress from earlier. And you can see that the recommended products at the bottom are still skirts, but they're not exactly similar to the products that the customer is currently looking at. Then on the right-hand side is actually using our model on their website and pulling in what we thought was the most similar products based on this computer vision approach and the encoding process and finding the most similar items. And you can see that the dresses are much more similar in look and style and feel to the one that the customer is looking at. And the thought process behind this is the customer is looking at a product that they most likely are interested in, otherwise they wouldn't have clicked on this product page in the first place. And what you really want to do is you want to get this customer to convert. And how do you do that? You make the customer's life easy. You show them products that are very similar to the one that they are looking at, because that's most likely what they're interested in at this point in time. Here's another example of a sort of long brown coat. You can see that the recommendations that came on the website for this particular retailer, some of them are similar, some of them are completely different. There's a sort of a dress there, and there's a blue coat, and then you can see the recommendations on the right hand side, which went through the prototype that we have, is the recommendations have become quite similar, and becomes, I think, a lot more useful for the user on the website. And then here's just a third example to drive the point home with the dress. The recommendations on this vendor's website were actually pretty decent, but then again, you can see that the recommendations that came through our system all had a very similar cut with a deep V-neck, which I thought was actually quite interesting. So if you are looking for a deep V-neck, it is showing you other options like that. Another interesting use case with this encoding process is you can actually push any image through it. It doesn't have to be an image that is already on the retailer's website. And then what happens is you can find a encoding for that particular image and then find similar images on the retailer's website. So it's a visual search. I find something on Instagram that I find interesting, I upload it on my favorite retailer's website, and then it shows me similar looking items that retailer has in stock. Okay, so some people actually have similar systems to this in place, and I did a bit of research to actually see how does it impact, or how do they report it impacts their e-commerce platforms. And you can see massive uplift across various different metrics, including session length, average spend, conversion rates, average order value, and obviously a very positive ROI. So let's go back to those problems that you had with the traditional recommender system approaches. How many of those problems still persist? Actually, none of them, but there is a new problem. the recommendations don't ever change unless products are added or removed from the store, because you are doing a difference metric and then just finding the images that are most similar to the one that you are comparing to. So unless new products come into the store or stock leaves, those recommendations will never change. What happens if the recommendations aren't that great or they become stale? And that's where there's a solution, reinforcement learning. And again, we built a couple of products using this technique in advert serving and also in voucher recommendations. And it's basically just a way for the system to learn by itself. So I just had a quick example here. So in traditional A/B testing, you show product A, you show product B, you wait some time, and then you conclude the conversion rate is better for product A, therefore go ahead with product A. What reinforcement learning does is it's a lot more sophisticated, but dynamic at the same time. So you can set up multiple products. So say these are the 4 products that were most similar, and you actually want to then see them compete against one another. And what the reinforcement algorithm will do is actually update the probability that a product will be shown in real time if you want, or in batch every day. So for example, you can show all 4 products, you wait for the clicks to come in through the days, and then you actually update the probabilities. So here you say, well, actually A and B had higher conversion rates than C or D. So immediately the next day, start showing more of product A and product B than compared to product C and D. And then you wait for another day's worth of clicks or purchases, and then you do another update. And what we've seen is you can converge to the best option 3 to 5 times quicker than traditional A/B testing. So the one negative point of using reinforcement learning is that it also has a cold start problem like traditional recommender systems. So if you've got 1,000 products in your catalog, you don't really want to show all 1,000 and wait for the system to learn, hey, what is the best products to show on this particular product page? Because it will take a long time for the system to start to optimize for the best. So the best approach that we think is actually to combine the 2 methods. So you take that computer vision approach, because that gives you a great starting point for your reinforcement learning algorithm. And then your reinforcement learning algorithm optimizes in a batch process daily to show the most relevant and best products on a product page at all times. And the great thing about that is you can sort of ring fence the period that the reinforcement algorithm can look at to make that decisioning. So you can say, well, only look at click information over the last couple of weeks. It means that the reinforcement learning algorithm is quite dynamic in changing recommendations based on seasonality or changing trends in behavior of customers. So it brings to life the recommendations that are provided by the computer vision system. So this is a prototype that we've set up, and we've run it on a couple of retailers without them even knowing, just to see how it works, and we think it's quite a good product. So there's some additions that we want to add. So we want to add in the product description text into the encodings, because a thing like a block of soap looks like all other blocks of soap. So how do you actually do that with the image only? I think it's quite difficult. So we are working on adding text into the system. And then the other thing that we are considering is actually mapping those encodings to a latent space. And basically what that means is you would then be able to say, like I think you've seen probably in these aging apps, you upload a picture of your face and then you say, hey, make me younger or make me older. And basically what happens there is you're actually moving on the sphere of a latent space. It's a good way to visualize it and conceptualize it. And we think we can maybe do something similar to that with the product images. So the customer is looking at a blue V-neck shirt, for example, and the customer says, well, I like this shirt, but I actually want a round neck, so shift my recommendations in that latent space and find me something similar to that. And then maybe you get there and they like the round neck, but they want it in a different color now, so then you can go along a different latent space to find the color that they want. So it's pulling the customer more towards that in-store experience, or closing the gap between online retail and in-store, and it becomes more of the customer engaging with a virtual sales agent, to find the product that they like. So that's all from me. Apologies again that I couldn't be there in person, but if you do want to talk about this more or are interested in applications of computer vision in retail, please feel free to reach out to me. More than happy to engage and speak about it more. Thank you.
Great presentation from Dino there. You would agree with me. Should you have questions, please reach him to him on LinkedIn. I just shared the link. You can connect with Dino, and he's open to answer whatever question you may have. We'll take a short break now, and up next, we're going to talk about blending artificial intelligence and virtual reality to improve our revenues. So we'll see you in a bit.